Okay, so we're officially meeting here. It's March 11th. And when we look at the schedule here, I'm kind of starting to map it out a little bit. But today we're going to talk about open data, and you're going to create some open data resources. Now, open data sounds like what it is. Data so that everyone can use it. And there's been a push in the last 6 or 7 years about the use application of open data. We're going to show a couple of examples. I'll have a little presentation, and then we're going to look at some of my open data resources and some of the things out there that we can do. Because next week, we're going to talk about data wrangling, and we're going to make sure Chantel reminds me that we're going to look at a project where we're going to go map gun deaths in North Carolina. You're nodding your head. Okay. That's the gun deaths in North Carolina, and look at some type of mini hypothesis that says, all right, gun deaths in rural areas are higher than gun deaths in urban areas, or vice versa. So we can go and prove and disprove some hypotheses, because in our other classes, we talk about the idea of assessment and evaluation. A lot of times when you do a master's or you do a project or a master's thesis, and definitely a PhD dissertation, you want to go and prove or disprove something. So we talk about this assessment and evaluation component. And so we'll circle back to some of the things we did with ANOVA and two-tailed t-test back in geostats, and give some people here an introduction to that, or a reintroduction to that, that we talked about previously. We'll look at gun deaths urban areas, gun deaths rural areas, and see if there's a difference, because we got to do some things like normalization and look at the rates, and all those other things out there that we don't really think of. Because if I said there's 23 in one area and 57 in another area, you're obviously going to say the 57 is higher. But if the area with 23 has a tenth of the population, then you're, whoa, the area with 23 is a lot less. So we'll talk about some of the caveats attached to that. And so next week's exercise is going to kind of take 2 weeks, where we're going to look at the North Carolina Vital Statistics database and get into big data wrangling. That's kind of my specialty, where that we're going to turn really big databases. And here, big for us is going to be 100,000 records, where that big in real life, when we start looking not at the Vital Statistics database, but we start looking at like the Board of Elections database, where we have like 7 million records, things that we can maybe bring into R, because Excel is not going to like those. Or to me, I like to bring these directly into GIS, because GIS can handle 7 million records. State demographer, we'll get into things called ICD codes, international classifications of death, Massachusetts death codes. So we can go look up what is a gunshot death and then query those out, because we've run queries before. Do we know what a query is? It's a question that we ask the data. And so we can start to bring these together, where we got to make the data first, and then kind of take these stepwise, take these steps into that. So next week's exercise is going to kind of focus on 2 weeks, and then we're going to focus next week, data wrangling, hypothesis testing. Week number 10, we're going to focus on something called data cleaning, where we're going to look at LRS data. They're called length route segments. Basically, every section of road in the state of North Carolina. There's like 1.1 million segments. Those of you, I was kind of joking with some folks earlier, where I did a lot of driving this weekend, so I had my little GPS unit. And so when you go from like one speed limit to another speed limit, even though you're on the same road, does your GPS kind of pick it up? Yeah. How does it do that? It's the same road, right? So how does it know like it changed speed limits? Because you're not really going on the same road, you're going on a new segment of road. It has the same name. And so when we start to look at these LRSs that are produced by state of North Carolina, there's like 1.1 million of these records. Bring these into a GIS, and we're going to do something called data cleaning. Hey, what is a legitimate speed limit for a road? Can we have multiples of 5? Can we have nulls? Can we have this? Can we have that? And so what we're going to do is we're going to go back to a little Python, where you're going to go and clean some of the data. Didn't we do this before? weren't we kind of looking up values like, hey, how many zeros here, how many ones or whatever? So we're gonna go and say, hey, what attribute, what field are we looking at? Let's make sure, not nulls, but hey, the speed limits better not be a negative number. The speed limits better not be this. The speed limits better not be that. The speed limits better be, 4 values. The speed limits, and so we can put together a report that says, hey, what do you want to do if it's a negative number? Or it might be flagging it, because remember we did that before. Hey, there's a null value here. I'm just going to tell you there's a null value. You figure out what you want to do with it. So we're going to look at those speed limits and figure out, where are they correct? Where are they not correct? Did someone type in an extra 0 and put in speed limit 300? Because when you do that and it goes and calculates your arrival time, what do you think it's going to do that arrival time? It's going to be there real quick. You're going to make you get there really quickly. Since distance equals rate times time. And so we're going to look at a really quote unquote bad data set, and you're going to have to go and kind of change it. Now, instead of null value checkers, what are we going to be doing? We're just going to be checking for odd values. And so you're going to be the one making up the rules for speed limits. And so we're going to go through the NCDOT data documentation and say, all right, what are the possible values for speed limits? Are there possible values? At some point in time, you're going to have to make the rules. When you see a speed limit 300, you say, well, okay, I guess we can have speed limit 300 because it says it here. There's nothing that stipulates that. And so at some point in time, you're going to have to make the rules for them. So we're going to just be taken off from that null value checker that we did last week or 2 weeks ago. And so now, instead of just checking for something that's null, and in the case of Python, none, we're just going to check, hey, do we have negative numbers here? Let's flag it. Do we have something that's over 100? Do we have something with a decimal point in there? And you're going to run into data that has all of those in there, So we got to figure out what are the possible numbers that we can have, because if it's not any of those, then we got problems. You got to go through and fix those. What are you going to fix them to? I don't know. That's something else we could do for another exercise, meaning where we're going to set up that edit, because all we're doing is reading. Well, in addition to reading, you can do something called writing to the data. Hey, if I see something that doesn't have a speed limit, but it has route class 2 or whatever route class 2 is, let's make it a speed limit 25. Do those things because there's 90 different attributes there. And so when we start kind of digging into the weeds with some of this transportation data, it's going to get really, really ugly, really, really quickly. But that's in data cleaning. Up there, and then that's week 10. Week 11, we're going to talk about metadata. Metadata are separate files, typically stored as XML files, but these days they're stored as what we call blobs, binary large objects within the database that can be accessed. So I can go through a database and just figure out when was this roads layer created, when was this towns layer created, and that was the big thing that I did for when I worked for the military. We had about 100 installations across the entire United States. Each of those would have between about 40 and about 150 individual feature classes within those. And my boss would say, hey, we're looking to do site visits to 10 of these. Which one of these has the oldest data? And so I would click the little plus button, click the little plus button again, and go through each of the individual metadata elements. And what do you think I said after a while? There's got to be an easier way to do this. And so back in the day, I wrote something called VB objects, but I've since migrated it to Python that says, hey, let me go through the metadata and figure out which one has the oldest publication dates, which one is even completed, which one has what's the name of it, which one has everything completed. So I can say, hey, in this database for Fort Bliss in Texas, they don't have any of the metadata completed. For this place in Louisiana, what was it called? Polk, yeah. Fort Polk, that was one of the ones we were in charge of, Fort Polk in Louisiana. Hey, we haven't been, the latest date that we visited was 2001. We're sitting here in 2007. That's a place we're going to have to go and visit because I don't want to go and hand click these. So we can toggle through. Have we done this before where you kind of go through each of the feature classes in a database and you figure out how many features there are? People are nodding their head. We did this already. And you told me which one had the most, which one had the least, and all that other good stuff. We're just gonna access another element for that because we accessed the data descriptive information. Now we're gonna access the metadata part of it. You know, information that you can fill in or we can automate in some way, shape, and form. So we'll look at some really rudimentary forms of that. And then week 12, we are gonna do machine learning. I am not gonna be here because I'm gonna be at the AAG conference in Hawaii. And so I'll be suffering there, our contacts at NASA have provided us with a remote sensing training course in fundamentals of machine learning, using Python, using an online environment. So I've kind of we're gonna work on that. And then the week after is the 22nd, where we're gonna have an in-class final for all grad students. So it's just gonna focus on code, everything that we've done. Code, open science, everything. Undergraduate students will not have to worry about that. And so the only concern for undergraduate students will be that final project. A couple people have approached me about some ideas here. I like the idea of kind of the gun depths where we're working with big data, we're doing something in this class, we're applying statistics, and we're applying it to something that I think is really interesting, not only socially relevant, but applicable to your research. Yes.
GERS projects will cover just the final project?
Yes, GERS projects will cover. So if you did you sign up for GERS? Okay, good. And so if you're submitting at GERS, did you submit anything for the North Carolina one or no?
So the one we're hosting here is the one I signed up for.
The GERS, okay. We're also hosting the North Carolina Geographical Society Symposium, but don't worry about that one. That's gonna be held over at the Student Center. So all the students that I'm supporting, I wanted to do that one too. See,
I signed up for one of them. I
Okay.
actually don't remember which one it was.
okay, make sure you figure out which one it is, because I would really that's something you need to figure out.
Yeah.
So, yeah, GERS is the one I like. I want everyone submitting to GERS. You know, I really like the North Carolina Geographical Society one just because we're hosting it here. And we'll but it's gonna be held on the 22nd of March. And so. Yeah, it's probably GERS. And so, but on the last day of class, we'll have an in-class final for grad students. We're gonna just do a little bit of small basic, a little bit of Python, and then a couple of things a couple of the principles. I'm gonna try to divide it up into like 10 equal sections, each worth 10 points. And I wanna do something that goes above and beyond what undergraduate students do so that I can call it a graduate, I gotta call it a graduate class, because if I have the same requirements for graduate and undergraduate students, it's gonna, you're gonna get in trouble, but more importantly, less importantly, I'm gonna get in trouble, but I wanna make sure there's enough content in there. All right, so we're gonna talk about open data here. Hopefully I've got everything kind of what we've got going on here. We're looking at about 6 more times that we're gonna meet in class. And starting like April the 8th or whatever, like that's the last time we're gonna meet all year. So because the 15th I'll be gone, and I've got that NASA tutorial that I'll post online. So right now we are working here in unit number 7, and I posted the dates up here as well. I'm going to talk a little bit about Transition to Open Science course by NASA. So they've provided Transition to Open Science. Talk about this idea of open science, ORCID, ORCID, the Open Science Framework, a project that I posted here. So here, basically, we're going to just learn about open science, open data, because people in my intro classes and whatnot, this is the big push for these days, are these open data portals. We have one called the NCCIP. So one of the funded projects that I'm on a project here where we have something called the North Carolina Community Information Portal. And this thing is focused on water quality education in the eastern part of the state. And so we created this webpage. This is using something called Esri Hubs. So Esri Hubs are basically interactive web pages. So you can create your story maps. Has anyone heard the term story maps? Okay, good. We have things called web apps. We have things called web maps. Web maps are basically maps that are ArcGIS Online, where that web apps are those maps, but you just can't edit them. Okay, so I give you a map, you can't add new stuff to them, you can't subtract stuff, you can't change the symbology to them. So they have a lot less functionality, but they're nice, pretty maps that people can look at in addition to dashboards, web experiences, which have some more interactivity. The story maps, which are pretty popular these days. So this is kind of a agglomeration of resources right here that we can create and we have access to. So if you want to start kind of creating one of these things, this is pretty neat. These are some of the communities we have. So we work with Greenbelt, Hyde County, Nags Head, Princeville, and then we have data and maps, resources and training. So I can click on resources and training. Some of these are just story maps about how to create a story map, how to create a free account, how to create a basic story map. So a story map on how to create a story map. Okay. Bringing data to life. Some of these are external links. Some of these are story maps that we've created. I thought I had some videos. Oh, cool. All these nice ArcGIS training videos. We all hopefully familiar with those, like running attribute queries, spatial overlays, adding data and whatnot that we have here that we'll be doing next week a little bit more. And then some external links here, the North Carolina Vital Environmental Justice Next Network and One Carolina Council. But the one big thing that we have here is what we call an open data portal. Open basically means all the data related to this project, we're popping it up here for people to download. And so you can see I've got one of 23 different resources right here, but I can type in anything that I want. So I can type in the word water quality. Here's all the water, anything that mentions the word water quality here. And so some of these are data sets. So surface water intakes, tap water database, animal feeding operations permits. And so these are animal feeding operation, North Carolina NC waste discharge permits. And so I can click on this particular database right here, or water surface intakes, and I click on it. Look what it's got here. A nice, pretty downloadable file right here, ready to go. And then what do you want to do? You want to view it? Do you want to download it? You can open it in ArcGIS Online. So these are things that we can go open, download, utilize, do whatever we want to do. One of the things, this might be a link right here, but I can type in the word counties. Here's a North Carolina County State Plane. This is a resource that we placed up here directly. So this isn't a link to something that already exists that someone else has. So you can see here full, look what we have here. Nice, pretty metadata that we've got sitting right here, ready to go. If I click back here, we're going to look at the metadata. Oops. Okay. It's a little. There we go. Okay. View full details. Okay. There it is. Okay. And so you can see read more. It's got different categories. Read more. I can view the table. I want to create a map, create a story. So I can go and insert these things into story maps. I can create a map with these data. I can view all the metadata attached to this thing right here. So if I right mouse click and click on open, this is the metadata for this. And we'll talk a little bit more about metadata here, but here I can go and download it. So I can download this as a CSV. What's CSV mean? comma separated value. So this is just gonna be a non-spatial, but Excel feature collection file geodatabase. That's what we work with in ArcGIS Pro, GeoJSON, JavaScript object notation, a shapefile, which is your kind of real basic GIS, GeoPackage, SQLite database. These are all the different file formats. Can we bring some of these into GIS? You bet. Go to the file geodatabase. We can download this thing that's sitting on our open cloud server right there that we can bring into this. So we've got a lot of capabilities here. This has got all the attributes here. We have a map here. Okay, we got a lot of different resources right here. And if I keep going back, and so if I go to the left right here, show 14 more, you can see all of the different files that I've got sitting here. Feature services, which basically they're like feature classes for cloud-based online data. We got web maps, document links, story maps, hub pages, because each of these are separate hub pages, forms, dashboards, discussions, PDF files, CSVs, collections. These are all the different files that I can click on. So if I just want to look at the PDF documents, here are there we go. Here are the PDF documents that are sitting right here. So lots of resources out there. Now this is related just for water quality education in the eastern part of the state. And one of the proposals that I just submitted today for the whole UNC system was creating one of these for the entire NCCU campus. So if you are like, I want to download cancer data, genomic data, business data, logistics data, anything from across the entire NCCU campus, we're trying to get something together so that we can do this. Now, I can't do this myself because most of you know how busy I am as it is. Chima knows how busy I am. He's got to wait an hour just to see me. But how busy I am. And so this would be something that we would go and hire someone a lot of money, like 6-figure money, to come and do, and then hire a postdoctoral researcher and pay them good money as well. And this is what we call CODE. This is kind of like my brainchild right here. And this is the Center for Data Equity. I used to call it CRADLE, Center and Resources for Applied Data Literacy and Equity, but I think CODE says it just as well. And so right now we're working with some of those resources, so I can type in the word county. I've got some issues right here with the backgrounds and all that other stuff, but here are all of my resources, all of my data. But you can't really see these things here. I don't know what's going on. There should be stuff being written here. There we go. So we got health equity reports, how to create a story map. We got a number of health equity reports here, Region 7 availability. This stuff looks a little weird right here, but we're going to go through and change it. But what we're trying to do and hoping to do is create kind of an open GIS data community for everyone, GIS, non-GIS, whatever, because you can download CSV files. Does someone in biology care about file geodatabases? They might, if they want to figure out where it was mapped, but, if they're looking at, satellite images, they do care about where it is, but other things they don't. And so we're going to make this, well, not we, someone is going to make this a nice searchable database. Now, other organizations have that out there right now. And one of them that we've utilized in our other class is the Durham Open Data Portal. I want to kind of focus on this here and talk about this a little bit, but FAIR it was just started, not just started, but there's been this really big push recently where that people aren't getting the appropriate return on investment for data. Because when, I talk about filing for grants or me getting this grant and NASA and all this other stuff, at the end of the day, who pays for it? Is NASA really giving me money? They're giving me your money. That's all they're doing. They're giving me your money so I can go and do this research. And so we need an appropriate forum so that we can get, you can get your money back here. And so there's been a push recently with fair, findable, accessible, interoperable, and reusable. Findable meaning I type in the words water quality and something comes up. Accessible meaning do you have access to it? Can I go and download it? And I think I see a big schism these days between the haves and the have-nots, between kind of this access to data and this lack of access to data. And really closing this data and this literacy gap is really important, because a lot of times if we go to the Durham website, it's just here's your data, but what do you do with it? How do is my grandmother going to know what to do if she goes and downloads the data? Probably not. And I think closing this gap is really important. I think the one thing that people don't think about is interoperability. What's that mean? We talk about maybe sometimes tightly coupled, loosely coupled applications. What does interoperable mean? Has anyone heard this term? Yeah, data you can use on multiple platforms. Believe it or not, there's other GIS platforms out there. GeoDa is one of them. Intergraph, other ones. Free one. It used to be called Grass, QGIS or whatever. So, if I'm downloading feature data classes or feature classes, that's going to be specific to ArcGIS Pro. That's not something that I can open up somewhere else, where that shape files are going to be something that are a little bit more software agnostic, because I've opened up shape files in other statistical software packages. And so interoperable, meaning, we can download stuff as Excel, or we're going to download stuff as .csv files that can be opened up anywhere. And then reusable, because the big thing with our research that we do is that if Chima or someone else downloads my data, they should be able to download it and follow things that I did and get the same exact results. And that's been really big push these days. And I've actually been on some board meetings here on campus for our IRB internal review board, where that people with misconduct issues related to research, like, hey, I went and downloaded their stuff and I'm not getting the same answers that they're getting. And we run into problems with that on not a regular basis, but probably once a year or so, when people care enough or have nothing better to do or whatever. Some of the things about findable data, metadata are assigned a globally unique and persistent identifier. Part and parcel to that are they're applied a unique URL. And since these things are services, you can click on add to story map, and that story map or that link to that data in there is going to be there forever. It's a dedicated HTTP www.ArcGIS Pro / something that's going to be dedicated to that resource forever. And so when we go to chapter 11 right here and get into metadata, we need to make sure now registered, index, searchable database, globally unique, persistent. All those are really big words, first of all. But second of all, these are going to be things that are assigned from a computer, but also they're described with rich metadata, meaning what's the project for, maybe what's the project number, who's the contact number, who's the contact information, and include the identifier of the information that they describe, because metadata transcends administrative, who's in charge of it, descriptive information, what's it talk about, and then structural information. What are all the attributes? I got something here called POP 2013. What do you think POP 2 stands for? Population 2013. But most of that stuff, most of that information is going to be auto-populated. Accessibility implies retrievable by their identifier. Standardized communication is free and universally implementable. And to me, that's where we kind of start to see this equity gap that exists between the haves and the have-nots. And the metadata are accessible even when the data are no longer available. There's various reasons why data may not be available, but we're going to talk today about examples where they are. And then interoperability, using vocabulary that follow FAIR principles. And then it's in a language that knowledge representation, we can bring it into multiple software packages and it's going to be software agnostic for the most part. Now, if I'm working with file geodatabases, I'm going to need, Esri, but you could see we had 6 or 7 different options so that we could download those data. And then we have reusable. Can I go back and redo this over and over again? And so that metadata kind of addresses these things at all, addresses these things. And this FAIR, and when you look at the actual article talking about FAIR principles, I can see it's been cited like 5,200 times. It's been accessed 692 times. This is in Scientific Data. Those of you familiar with research out there, if people have cited your work 5,300 times, that's a really good thing. I think the most my work has been, what is it, 30, 35, something like that, So if we're at 5,000 for just one work, that's really good. Those are the things that we care about. The other thing that I'll mention here before I get into my little spiel here is the idea of care principles, or that we're sensitive to indigenous cultures. And so you can see some of the care principles. I'm not as familiar with those, with the care as it is, but it's a real focus on indigenous data, indigenous knowledge for the collective benefit of all. And when it says all, it means all. And so I thought this was kind of interesting. You can kind of look at some of these, but you can see some of the representation from, New Zealand, South Africa, Australia, Italy, Canada, or whatever, where you have large amounts of indigenous populations that still exist, or First Nations, or whatever, whatever exists in those particular countries there. And so it's a sensitivity to utilizing data that is going to be sensitive to their needs as well. That I think are often overlooked. We'll look at this one later here, but we've got the Open Durham Data Portal. So one of the things that we do in class right here is I can go and type in the word crime. I've got links to these. I'm pretty sure I have links to these, but I want to look up crime data here for Open Portal. And most of these kind of agencies, counties, states, and whatnot, really have directives to make your data open. Now, how open? We'll see how open these are. But I can go to crime data for NCC, for the city of Durham. You can see we've got feature services, Excel, Microsoft Excels, web mapping applications, CSV files. The one thing about Durham County is that they've got separate sheriff's data, and then they've got separate DPD crime data. So if you were to map county level crime, it's going to be a combination of sheriff's data, and Chantel, you're familiar with crime data and the actual Durham Police Department. But when you look at the actual data themselves for the sheriff's office, the attributes for the sheriff's office are different than the attributes for the police department. So even when you go and combine those together and say types of crime, dates of crime, the way that they store the data are entirely different. Yes, I asked those same questions myself. I don't know why. Okay, Chantel can probably tell us why. They probably have antiquated systems from back in the day, and they just, yep. And so we can see, weapons codes, and all of these mean something. So I'm not saying that it's silly or different or trying to be different here, but you can see, the officer ID and everything else, or that if I go back to crime data and Durham Police Department, we can see date reported as, charge description, this field. There's a lot less attributes. These can be mapped right here. What's this process here by which I can turn this address into a point on a map? What's that called? Geocoding. Has anyone ever geocoded before? Have you ever typed in an address? Yeah, we do this all the time. Now, Do we want to go and do it 132,000? Has anyone done it 132,000 times? You did it.
Automatically, yeah, automated.
Yeah, automated, it's not easy, but it's, now you see some of the problems here where you see 300 West Morgan Street / Foster Street. Well, how does that go into? It's gonna be hard. Because the police officer probably taking the report, this is what they typed in, because this might have been an accident at this particular block right here. And you can see this information is stored at the block level, to help protect the anonymity of people suffered from vandalism or DWIs or intimidation or whatever, especially when we get into like situations like domestic violence. But some of the things I can do here is, one of the things I can do is I can filter these data, basically running a query on these, but I can go and download these. And so I can click on the little download button, but when I do, it only gives me CSV. So it's not sitting there saying, hey, I got a feature class for you. And one of the things we're talking about in our crime analysis class is that we're going to do something called geocoding, where I can bring these CSV files into my GIS and then just map them right here, because we don't have the options here. When you clicked on it, you didn't see a map of anything. All this is just the table that's being posted. Those people over at the sheriff's office, the police department, they probably don't know anything about GIS except for the person who sits in the back corner and says, make me maps, where they do this. And so these data are updated on probably a monthly basis or so, and we can go and, filter these data. I can click this little filter, and I can say charge description, and anyway. So we've got a whole bunch of murder, homicide, non-negligent, whatever that, these are here. I can go and map these. You can see some of these are as current as like 2/12/2000, literally less than a month ago. And we could see where it occurred. We can move to the right a little bit, and we can map all of these or filter these out however we want. And so instead of me downloading 132,000 of these, because it takes a really long time to do this and prep this, we can download the ones we want, bring these into a CSV file, and open these up here. But these are some of the data sitting on the Open Durham website. We've got other resources available to us right here. I swear I know what I'm doing here. Come on, there we go. So they got data stories, dashboards. And so dashboards is a big thing these days. So it's pulling data maybe on race and ethnicity here for Durham. And so did we make this map? Did anyone see the URL up there? degs.map. That's us. Who did this? Who did? Oh, you did it during the summer? With who? Samuel. Oh, okay. All right. So yeah, one of our students, I guess, did this, and they posted it. I think he was working with Durham County. Yeah, he was working with Durham County, created some of these dashboards that look at some of the demographics here, because people like to look at this stuff too. They don't want to go and download, rows and rows of files. So we can look at high school education attainment or whatever, college education. Some of these, this is Samuel, who's now working over at Esri. What else? Data stories, data catalog. We kind of looked at that, and then we've got some maps and apps right here related to enforcement, sex offenders, demolition permits, some maps right here. So they've done a fairly decent job of putting some of their data and maps up there. And it's our intention to kind of put our stuff up there as well, everything. What's that? Yeah, they used hubs, and then they just made a open site to do this. Who's doing this over there? Ryan, or do you know anyone over there?
For the stormwater.
Okay,
Somewhere.
okay. Yeah, someone over there does that, I don't know who, to be honest with you. And it's a matter of just checking the box and doing a couple other things. We've got something up there called North Carolina One Map. These are related to the state of North Carolina. We got Open Raleigh, and so we can look at public safety about Raleigh, transportation, housing, parks and recreation. I don't know much about these, but I assume this is probably going to be a hub as well. And when you download the hubs, these people aren't going making these things, web pages from scratch. You've got templates that you can utilize. And if you go up to the upper left, you see data.ral.opendata.arcgis.com. How did I know that Durham one was created by us? Yeah, I looked at the URL and I said maps.degsnccu.com, and I was like, whoa, we made that one. That's pretty cool. And so a lot of times, not a lot of times, but when we open up and avail these data resources, we can click on these. So I can click on parks right here. I can go and download these. I can share these. I don't want to share these, but I can download the outlines of all the parks, CSV, shapefiles. If we're starting to look at things like file geodatabases, GeoJSON, shapefiles, feature collections, those are going to be GIS. Notice when I open up the crime data, I just started looking at a table. So we've got different ways that these data can be shared. I look at public safety right here, and I can click on, police incidents. I click on the police incidents, and you can see that, oh, I do have points right here. Someone's actually gone through and already mapped these over in Raleigh. And so they went through and did a lot of the heavy lifting, so I can download these as a shapefile, KML file, which I can bring into Google Earth and bring these in as well. And then GeoJSON, it's just JavaScript object notation, and the geo means it's got geographic data related to it. So it's just another way to represent spatial data that can be understood by other software applications. So it's nothing too much to be concerned about, but we've got open data here. So we got Durham Police Department. We can see everything that they've got here. And so there's been a really big push related to open data. So I'm going to talk a little bit about some open data applications, open data resources. And then basically what we're going to do is you're going to take the NASA TOPS Transition to Open Science class this week. And then you're going to make yourself an ORCID. It stands for like Open Resource Identification, so that you can see mine, I can see yours. It's basically a universal resource for you. And you're going to post some data to what we call the Open Science Framework. Now, it could just be a drone image that you collected, in class. Say, hey, this is a drone image that I collected for the world to go download that'll have a dedicated URL. URL is the little HTTP up in the top there, or sometimes in research papers, they're called DOIs, something object identifier, some sort of distinct object identifier or something like that. So it's dedicated object identifier. That sounds really cheap. With it, digital, yeah, that was it. Digital object identifier that's going to be unique to that resource. And typically they're papers or whatever, but open science could be the drone image that you captured, maybe some of the data that you've collected for your those surveys that you're taking related to food staple prices. Okay, or anything, some of the data that we're working with. And so I want us to kind of get in the habit. It's a hard habit for me, because most of my data is sitting on my little hard drive, my little flash drive, which are stored together. But we really want to make this push for posting this up there so it could be, replicatable. So someone can download the data and do the exact same thing that you have.
Where is it posted? is this cloud data?
I don't know, wherever the cloud exists. Yeah.
Or so you said it was hosted by NASA, right? They're championing it.
Yes, they champion this push, but like we have cloud space at Esri, which is gonna be on their servers there. If I really want to and really was dedicated to it, we could create our own cloud space here. You know, and I bought a little cloud server. I'm figuring out how to use it where that I can just click and drag my stuff there, and all it is a hard drive sitting right next to my Wi-Fi router where data is stored. It's just got a dedicated IP address or URL that knows it's sitting there as opposed to anywhere else in the world. So that's the big thing. So when we go to NC1 Map and bring in the imagery, we're not, I'm not carrying around 27 terabytes of data. They're worrying about 27 terabytes of data sitting on their resource there. So I'll talk a little bit about these. I won't go through all the slides. I just want to kind of make sure I reinforce the importance of open data. We take a step back from programming or take a break from programming a little bit and kind of focus on some of the finer points of open data, the importance of open data, and us includes me getting in the habit of posting this stuff up there, because when you write a research paper, they're getting to the point where you need to put a universal resource locator or DOI, digital object identifier, for the data that you have up there. And if I think of it, I'll kind of highlight on one of my papers where I had to go and save everything up there to say, hey, when you fill out the paper, you've got to fill out this little form that has a little red star that says, nope, you need to complete this. So you need to put the little URL there. And so I'll talk about a couple of those here. But when we talk about metadata is important as well. We'll talk a little bit more about that. But we talk about open data, open government data, the Durham, Greensboro, I kind of highlighted before. They have a lot more focus on their police data and their incident data. Now, they have incidents, they have arrests. And so what's the difference? You have an incident where it might be intimidation or something like that versus arrests where it leads to arrest, but the arrest might not occur until you get downtown, which is really skews up everything. So there might be a lot of kind of work in the middle to do these things. So open government data, policies, initiatives. We're going to just kind of look at a couple case studies with apps and services, because I really want to focus on some of the stuff that I'm doing, because I want us all to create an ORCID, because that way you've got a universal resource locator directly related to you for your research and your papers and your everything else. Because if you don't advertise yourself, who's going to advertise you? No one is, because I'm going to advertise me. I'm not going to tell everyone how good Benjamin is. In this department, I will, but if him and I are competing for the same job, I'm not going to tell everyone how great he is, because when you go and apply for a job, it's a pass fail. You did really well at the interview, but we're still hiring someone else. It's not an A-, it's an F. And so really being able to promote yourself out in the academic world for our PhD students, or the professional world for our PhD students and everyone else, is important. It doesn't start when you graduate. It starts like now. It starts now so that people can get your name out there and, hey, I remember this person, we like this person, or whoever. And I'll start sounding like my parents, but get your name out there now. Once you graduate, that's probably too late. I don't want to say too late, but you're behind the 8 ball a little bit. So presenting at like GERS or the North Carolina Geographical Society Symposium, because the last person we hired, why did we hire him? Because we liked him. We already knew him. We just hired a new professor. This was Theo. You guys know Theo Nussi? You go know him? No. Well, he was one of our students. So we're like, hey, Theo just graduated. Let's interview him. So Dr. Mulrooney did. But no, Tim now. Forget about that. Just call me Tim. Okay, no Dr. Mulrooney. Okay, but we'll talk about some of the linked data because I do want to kind of highlight and get in the habit of posting our data out there, because you're going to publish a paper and they're going to say, what's the DOI for your data? And you're going to say, what's a DOI? And there's a lot of repositories, online repositories out there, which support kind of this open data, governance of data, metadata, all this other good stuff. So at some point in time, you don't have to re-download the data, especially if someone else has created it. And so some of the important things are the availability and access of data. And we're going to open up some of the data that I've created on Open Science Framework. USDA has something called Ag Commons. NSF, I'm sure, has something. NIH, I know, has something out there, NIH, National Institute of Health. We want to reuse and distribute it, and we want universal participation. So this kind of harkens back to the idea of our FAIR principles. I think it's really important that we kind of reiterate, especially us serving, teaching at minority serving institutions where we see the schism between the haves and the have-nots, having access to this data and the technologies to facilitate this data. I think we're really working hard to close we're really working hard to close that gap, because everyone in this room has access to very expensive software. Esri, it's just a matter of you going to training.esri.com and you getting the training, or figuring things out, or going to videos. These days, it's not sitting here in a book. Tons of people out there have done this here, and so. Non-commercial restrictions that prevent commercial use restrictions. And so when we complete metadata, there's lots of information out there. There's like 410 elements out there. For the online metadata, it's a lot less, but it's still going to be searchable. And so a lot of times we can say search Europe's public data. We can do the same thing for our NCCIP, North Carolina Community Information Portal. There's about 123, 125 individual resources that you can select. Some of these are documents, some of these are PDFs, and some of the thing that we're doing with our code repository is I'm uploading my PDF documents of my papers and putting them up there and making them searchable and doing everything up there so that you could just look at papers, look at length, look at story maps, look at movies, look at raw data. Because at the end of the day, how many people, when you just think of, maybe everyone in here wants to use this, but is the average kind of user going to want to download crime data to a CSV file? Probably not. They're just going to click on a map and see where stuff occurred, or look at all the permits and say, hey, my neighbor's building something there. Do they have a permit for that? Let me click. Oh, yes, they do. Because I was looking at the permit map up there. And so those are some of the things that are important. Now, there's going to be instances out there where the data is going to be sensitive or private. What are some instances where data might be sensitive or private? And I think sometimes county level organizations really fall through the gaps here. What are some instances where data should be private? With that, health related data. And that's a good one because we've worked with Places database, and next week we're going to look at the vital statistics database, where data are agglomerated at the zip code level. So it doesn't have the exact address of where someone got shot or someone was killed or died of this particular disease. They're grouped within zip codes. Now, if you really want to, you can contact the North Carolina Health Department, and they've given me like a list of everyone who died of cancer by address and everything, which is really interesting. But you're mapping that at like the street level, using some geocoding procedures, but they make you promise like, hey, you need to group this in census tracts or zip codes because that's sensitive information, HIPAA and all those other things. I always think of things like domestic violence, stalkers, all that other stuff. I'm sure, unfortunately, someone's dealt with those in this room here as well. But you can go to like the North Carolina or Guilford County GIS website and just type in someone's last name, and you can see like what properties they own. Like, if a stalker knows how to use the North Carolina GIS, they can probably do that, even though everything else has been kind of privatized. You've kind of hidden your phone number and everything else. But, does the North Carolina GIS or North, the Guilford County GIS get that same memo or whatever. And so I think, having an understanding of the sensitivity or privacy of some of these data that we have. Other things, we want transparency, releasing social and commercial value. Some other private data out there are data that are collected by like ad agencies, marketing and things like that. And so we start to look at things like spending patterns. Spending patterns are really, really important. Nielsen ratings, which you see on TV, basically what commercials are people watching, what television shows are people watching. These days, I'm sure it's really difficult with streaming and all that other stuff. I don't know how they figure that out. And then try to reduce government costs related to some of these things. When someone looks up URIs or URLs, provide some useful information, linked data, and that's going to be a bigger thing here with the creation of services. Like Benjamin alluded to, when we talk about cloud, it's sitting on some computer somewhere else that has a dedicated URL or probably IP address attached to it that we can click on. And so when we went to some of those sites right there, it said add it to a story map. It didn't say download, add it to a story map, and it knows that data sitting there because you can add it to a story map and you can add it to a map and you can add it to a web app. We can do all the same things here. And so it's important that we have those. We also want to increase data quality, flexible data integration with everything. But so there are some real value-added applications, the use and application of government data. I like those, and these are probably like the last 4 or 5 years that these open data websites have been created. Previously you had to contact someone and they'd send you a CD and you'd have to kind of install it and, download it. It's kind of difficult. We can download like imagery from the 1900s, from NAIP, National Agricultural Inventory Program, by going to something called the National Map. Has anyone heard of that before? Just another data resource out there. Go to nationalmap.gov, highlight the area. That's got all of the satellite imagery that you have up there. When I started doing GIS and remote sensing, like you had to send letters to some place in South Dakota that was head of EROS, E-R-O-S. So you can I want to get the satellite imagery for this Landsat satellite on this day, and they'd send you back a CD that we'd stick in there. Does anyone even know what these CDs are? I got my kids, they lay around my house or whatever, but sticking them in a computer, do we have any CD players here? No, they're obsolete, absolutely obsolete. The whole idea of data politics, what are some of the rules related to these? Open data portals right here. And so we have these national, regional. National Map is just a great example of a national level web portal. To me, it focuses a lot more on imagery, but it does have some rudimentary data out there. But our local level portals, if you go to NC One Map, we're still working on getting the data for imagery for North Carolina One Map. Their services are down, but I think there's a lot of neat things up here. Make smarter use of data. I think I tell everyone, work smarter, don't work harder. Downloading tons and tons and tons of stuff it's kind of boring. And so be aware of those. And then a couple other things, kind of public and businesses are provided a better and more efficient service when data has already been recorded, shared across institutions. So we need to be kind of just cognizant of those. So if we have our open data site up there and we've posted data up there, then I don't have to go through the trouble of recreating it or reusing it. Because my first question that I'm always going to ask is, what are we going to do to it? Where are we going to get the data? So when I hear a project about, I want to look at all gunshot victims in 2022, I know exactly where we're going to get the data. Now, she might want them at the local level. Well, I'm going to have to, we got them for you at the zip code level, but they're already downloadable. She's going to do some things with those. And once you manipulate those and change those from the native data set, I think we can do some interesting things and post those up there. A couple other things, some general principles. Let me see if there's anything. And basically what we talk about here is just, we go through all the open data policies for different European countries, because I think they're a little further ahead in terms of they're open data as we are, like Open Durham, Open Raleigh, Open Greensboro. NC1 map's been around a while, but those of you familiar with state of North Carolina, and the state of North Carolina is really on the kind of the front end of providing open data, GIS services and GIS technologies that have been integrated with state level GIS. Every other year, we have a North Carolina GIS conference right around this time of year. It's every other year, so it'll be in 2025, which is really good. It's one of the largest attended GIS, state level GIS conferences in the country. I love it. We take people, we took a bunch of people last year, like 8 people to it, 7 or 8 people to it. We had a couple students win awards, and then every other year, our top undergraduate student and our top graduate student get something called the Herb Stout Award. And so basically it's just voted on by the faculty. So our top undergrad and top grad go there and get recognized, and they also present there as well. And that's a really good experience. Students get like $30, admission. And I'm kind of dealing with travel about getting reimbursements on all that stuff here, but that would be something to go to. Cause I think did I put students up there or did they just go for the day? Did I put you guys up in a hotel last year time? Okay, so go for the North Carolina GIS conference. It was over in Winston-Salem.
I think so.
Okay, yeah.
I went to,
AG, where's that? Denver? Okay. Yeah, Denver. So, yeah, and later this year, we're gonna have something called CDAG, Southeast Division of Association of American Geographers. That's gonna be in South Carolina. And I have to be part of it, so I'll probably take some people to that. What's that?
What part of South?
Greenville. Are you from there? Okay, what university is there? Is that Furman?
Furman
Yeah,
University.
Furman, I think. Yeah, Furman's hosting it. So I always encourage people to present and, especially kind of some of those smaller forums there, so. But I'll talk more about that later here. Estonia has one here, France, the G8, other things. So here's some case studies on these here, like worst stations for finding a bike, best stations for finding a bike. And kind of the list goes on and on. And with the integration, the creation of this hubs technology, it's just, it's website. You don't even have to write HTML code. You don't have to write any code. And so we've got a lot of kind of applications here, open companies, linked governments, PSI directives, all these other things here. Public sector information, and that's about it. So with the rest of the time here, we're going to focus on exercise number 6. I'm kind of looking to see if anyone nods. Okay. I think it's exercise number 6. But we're going to look at exercise number 6. I want to give people a chance to start on it because this is going to be a little bit different than previous exercises that we've got. And I'll kind of point you all here to me, and I'll keep sharing because it looks like my share got lost. So when we look at the okay, all right. So when we look at the courses right here, we've got exercise number 6. I'm gonna click on these here in a little bit, but we have ORC, CID resources, ORCID, and we're gonna talk all about these. The Open Science Framework, which is basically a repository so you can put your data up there and make it searchable for everyone. I'm gonna go down to one of my papers here because I'm pretty sure, not pretty sure, I'm just about positive that I had to put something up there. Agriculture and food security. So this is a paper that we did. Okay, cool. This is the paper that we did. I think Chima's on this. Tony, you're on this too, right? I'm pretty sure, yeah. Me and Chris, this was kind of a project where we were measuring access of food. How do you measure how close food is to you? How do you measure it? travel time, that's one of the ways, right? Straight, but that's hard, meaning figuring out the travel time between you. Now, am I gonna do it for every house to the nearest location? Why not?
Too many variables.
Too many variables. So I asked, are we gonna measure between the house and the nearest food source? There's too many variables and there's a lot of calculations because when you type in the directions from this house, from where I am to the nearest wherever, it's doing hundreds of thousands of calculations a second. Now imagine doing it for the 1,000 houses around it. You've just multiplied it by a factor of 1,000. And so it starts to get really robust. And so things like, all right, how many grocery stores are in your zip code? That's another way. And so we can look at things like travel time. What about just the distance from the middle to the nearest grocery store? That's okay, but what if the grocery store just happened to be right near the middle as opposed to one that's further away? And so what's the definition of the middle versus the population weighted centroids? Let's see if anyone perks up when I say population weighted centroids. Oh, Barbara knows that. Yes. Okay, good. Oh, is Caitlin here with us today? Oh, I don't see Caitlin. But I know Mac knows what population weighted centroids mean. Oh, good. Okay, but population weighted centroids, that's actually a better measure here. But we measured a number of different ways. This is a neat paper, it just got published recently, where we looked at dollar store availability. Why we picked dollar store as opposed to supermarket, we saw the proliferation of dollar stores in rural areas as kind of an alternative fresh food source, especially the Dollar General around the corner from me that serves milk and eggs and bananas at close to like supermarket prices, which I thought was interesting. So we saw that they've kind of doubled in size over where I've lived. But this paper right here is right here. This is what I'm trying to prove right here. We go through and do this research, but we talk about different methods. There's one called point density, drive time. Like Cameron alluded to, drive time is how long it takes you to drive, and specifically from the middle of the census block group to the nearest supermarket. So there's going to be some bias there. We have something called join count, basically how many supermarkets are in your block group or zip code. This is a buffer. How many supermarkets are within 3 miles of your zip code? 3, 7, 23, 82, 79, however many. We have something called Euclidean distance, store density. And so basically that's joint count standardized by density. So if there's 3 stores in my zip code and 3 in your zip code, are they both the same? What if one zip code is twice the size of the other? It's a lot different. And then we also did that store density by population. If there's 3 in one zip code, 3 in another zip code, but one has 3 times the population, well, the one with 3 times the population is actually doesn't have as many stores per 1,000 population or whatever. And so we're looking at about 7 or 8 just different methods to measure how available is food to you. Did any of you think about that? When you went to data science class, that you think about all these availabilities. And this gets into what we call the assessment and evaluation model here that we're going to get to. Assessment is this nice little chart. And I know Cameron's seen this chart before. Have you seen this chart? Yeah.
Something similar.
We saw something similar to that when we talked about correlation matrices, correction matrices in class today. And so this is an assessment and an evaluation. It's just, okay, 1.9. Basically, this kind of just shows how well these maps agree with each other. So 0.7, one agrees with it 70%, 63%, 81%, 61%, 22%, but 22% is due to the granularity of the data, meaning it could be either 0, 1, 2, 3, or 4. Not 1.7, 2.3, 9.7, 4.2. And so there's only like 3 or 4 different values that you can have. And so it's difficult to make associations with those. And so we went and kind of did this different method here. You can see how we measure these. You know, this is probably, and we wrote a little Python code right here. So we got a little Python code right here. Does this thing kind of ring a bell right here? Input parameters, all that other good stuff right here. But at the end, here's my evaluation component right here. But at the end, that was required was acknowledgement. Who do you wish to thank? You always have to kiss the rear end of the people who reviewed the paper, meaning thank you very much for all the great, updates and edits that you suggested for. Even though a lot of times they're very vague, like it needs to be improved. Like, I don't know what that means exactly. The English needs to be improved. Like, I don't know, give me an example of the English that needs to be improved. I don't know. And then we have author contributions, meaning who contributed what, funding, people who give you money, they always want to be recognized. But right here, availability of data materials, the data sets supporting the conclusions of this article or report are available in the Open Science Framework. And I can click on this little thing right here and look what I've got here, Open Science, so that anyone, okay, and guess what we're going to do later? You're going to create an account and you're going to do this for yourself, where these are the results. I ran something called the Jaccard Index. And so now I can go and download these data. And if I follow the directions enough and what I did, you can be able to do the exact same thing that I just did. So you can go and download this data that I used to make this paper. This, to me, this is really kind of cutting edge, like not, I don't want to say cutting edge, but really forward thinking in the last 5 years. 15 years ago, if I called someone up and said, hey, I like that project, could you send me your data? What do you think they'd say? Now we're writing papers here in really big journals. This was the Journal of Agriculture and Food Security, I think it was. Like, you have to put where you got your data from, and you probably shouldn't put Google Drive, you could put it, somewhere, I don't want to say legitimate right here. But now I can go and download this, and then look what I got right here. I've got a really rudimentary data set that says this is the DOI for it. This is a digital object identifier. This was the data was created, modified. This is a description of the data. Here's the funder, award number, and I've got it all sitting right here. Very rudimentary metadata about this thing right here. And so I can go and download this or do whatever, and you can see all of the things, all the data that we've created here. And you can see we kind of did some two-tailed t-tests. No, we didn't do two-tailed t-tests. What did we do? We did some categorical testing and then did some Jaccard indices on this here. I wanted to use that as my tool because I kind of go to the two-tailed t-test probably a little too much. But here I can go and download everything sitting right here. Where's my little paper right here? Get rid of that here. Okay, I really know what I'm doing here, so here. And then when I run the Jaccard indices, so you can see here are these things right here. Okay, so these are my results right here. I made them look pretty. I made them fun. I made them look pretty in the actual paper, but these are the results of the Jaccard index here. And I did some things down here where I ran some summaries and average and means and modes and all that other good stuff that wasn't included as part of the paper, but this stuff's sitting right there. And what we're going to do for homework, and we'll go through the homework in detail, is you're going to create something, you're going to create a web page for something that you've done before. I don't care what it is. You flew some imagery, you created a cool little map of the Dr. Shepard statue across the street. You're going to post that. Hey, I did this geostats homework. I wrote a geostats paper. Here's the data in support of my research paper. And that's all you're not going to have to do anything technical or two-tailed t-test or anything like that. So I want us to get in the habit of doing that. And so when I open up the homework, there's going to be 2 major assignments, or probably a couple and a half major assignments right here. But the first one is going to be, there's a NASA course, and we have a big grant with NASA. It's paying for a lot of people here. I think some people in the room here. But one of the things we're going to do is we're going to take the NASA course entitled Transition to Open Science. It's called POPS. So we're going to do a transition to open science. And basically, it's just going to be a course that we're going to take. And we're going to learn about open science fundamentals related to NASA. So we can cut and paste this thing in here. I've gone through and taken some of it already, because when I click enroll, this is Open Science 101. It's a 5-module curriculum designed to equip researchers, students, and citizen scientists with the knowledge and skills to navigate the principles and practices of open science. Citizen science, I think, is a real big thing that we hear about. We, over in our project with our project called COPE, Coastlines and People, we call these people facilitators. We used to call them interns, but interns sounded a little on the young side, so we call them facilitators. So people who kind of work out in the community and have access to these data so that they can download like the water quality data for yesterday and do stuff to it if they really want to. Most of them will probably look at neat stories and pictures and maps and videos, but if you really wanted to, you could download water quality for yesterday and map the specific conductivity and O2s and all this other stuff if you wanted to. And I think that's neat. That's really neat here. And so I can click on enroll. Where's the enroll button? Okay. Self-paced virtual testing. We don't want to take this one, so. And then sign in. And so you can sign in using a username and password, or sign in using your ORCID. And so part of this assignment is you go and get yourself an ORCID. Okay. And so make sure you save the certificate as a completion. So once you sign in using your ORCID, so now I can go sign in. And it's got a little button down here that says register now. So this is just like registering for a new service, app. Everyone gets sick of signing up for stuff, right? I do too. This is another thing you got to sign up for. But this thing will let you into like a lot of government sites. And then you can see right here, I'm taking module 1, the ethos of open science. And then there's my little username, TimMull72. And so you can see the courses that I'm taking here. So at the end of the course, you go and you get that. But while you're there, go and get yourself an ORCID. No. Because this is mine right here. So I've got a dedicated URL. And so these days, when you submit grants to like NCDOT, probably not NCDOT, but like National Science Foundation, NASA, you need to have one of those things up there so that I am 019993, that whole number. That whole number, and then I can add everything to it, and you can see all of my papers that I presented here. So that I've got individual DOIs located to all of these journals that have that publish or give DOIs. And so all of my papers that I've got sitting right here since 2017, here's the DOI for all of these. And so what I want us to do at some point in time, hopefully attached to this, is that now I can sign into NASA TOPS course using this ORCID. And so there's a lot of cross-pollination between these things here. So I think it's really important that you get yourself an ORCID, are able to sign into NASA and take the NASA TOPS class, Transition to Open Science. So once you sign in, you can just Resume, you can see I'm taking the class right now myself, but okay. And so let's just go, what is open science? The ethos of open science. It's got these activities, curriculum bookmarkers, kind of these online classes that we have here. These were created by our partners at NASA, so they want as many of our students and as many of their awardees to take these as possible. So to me, I don't think this is technically too hard, but there's a lot of different prongs to this, where you got the transition to open science, you got the ORC ID. And so anytime you publish a paper, this ORC ID is going to be updated. Once in a while, you get an email that says, hey, is your name Tim Mulrooney? Because I see a Timothy here. I'm just making sure, And so every once in a while, you'll get some updates related to those. But this has got the ethos. It's got activities. What is open science? Why is open science? Why is open science important? And so I think this is a really good class to take. It's probably something you could probably do while watching Netflix, or whatever you kids watch these days, But I think it's kind of some low hanging fruit. And I think some of these buzzwords that you've heard me talk about in the last hour and change are going to kind of come up with these. So I really want to kind of hammer it into people's heads here that, once you create something, publish it, put it out there, put it on our hub, put it in code, put it in something that we want out there, so that, at the end of the day, if we see something really cool and I see the words Cameron Schuler on it, those are things that I'm gonna remember. Because if you're not advertising yourself, then guess what? No one else is. And the person who is advertising themselves, they're gonna get the job, or they're gonna get the contract, or whatever's out there. You are your own best self-promoter. And I think this open science is really, to be honest with you, I don't want to sound hyperbolic, but it's really leveled the playing field in terms of, where Duke and NC State, they have their data visualization centers and their dedicated URLs and their whole staff to do all this stuff. But now we just have a hub, click a little button, and then you can have your stuff published up there. And as long as you got your metadata up there, your stuff and material is as good, as open as anyone else's out there. And so I really implore people to kind of focus on this open data here. So part of this exercise, or the first part of the exercise, is get yourself an ORC ID, and then go and take Open Science 101. I've got links to those, and we'll kind of revisit those here when we get back to the modules. The second thing is Open Science Framework is a tool that promotes open centralized workflows by enabling capture of different aspects and products of this sounds pretty cool. I'm surprised that I wrote this. Research life cycle, including developing a research idea, designing a study, storing and analyzing collected data, writing and publishing reports and papers. And I think this open science really covers the whole gamut of the project phase. When you create data, creating your raw data, the analysis of this data, and then the cataloging of this data can be done through open science. And like I said before, there's a number of different open data websites, repositories out there. Open Science is just one of them that I heard at some meeting a couple of years ago, and say, hey, publish your stuff to Open Science Framework. And so this is the Open Science Framework. This is the data that I have sitting up at my Open Science Framework. I think this is another website. Okay, this is one that we did with a PhD student, where that, and this is called osf.io. But this is geospatial associations between female breast cancer, mortality rates, and environmental socioeconomic indicators. And you can see in here, I've posted the death by year. So I don't even know what I did here, but I'll just blame Alana for all of it. So it doesn't even matter. But you can see I've put a little description here. This is the DOI I have for. It was updated last July. But these are all of our data sitting there. So if you go and look up our paper, it's got a link to that we can download the data sitting right here and replicate what she did if you really wanted to. And we looked at some of the raw data here. We made some charts and graphs, but this was female breast cancer data, and specifically she was looking at African-American female breast cancer death rates and how they differentiate than other races in North Carolina. And you can see some distinct differences, especially in the bar charts, how, the average age of African-American females is like 55 for breast cancer, while for everyone else, it's like 62. And so we ran some 2-TLT tests related to some socioeconomic environmental variables to look at, hey, where female breast cancer rates are high, they have lower income. And so in the next couple of weeks, we'll kind of revisit some of the 2-TLT tests and the 2-TLT tests and the ANOVA testing that we've talked about previously, to how do we not only make those statements, but we reinforce those statements and back those up with sound assessment and evaluation techniques on the backbone of statistical methods. That was a pretty good sentence. So, but we've posted these data here as well. But for the second part of the exercise is that I want you to go to Open Science Framework and create a DOI or another site using Open Science that you're familiar with, not Google Drive. Do not use Google Drive. Use something like official. So I would use Open Science Framework. If people are familiar with Ag Commons or some of the NSF ones, you can, but I would just go to Open Science Framework, and in the discussion board, post a link of your DOI that I can open. So what you're going to do is you're going to post a resource that you have from research paper that you've done, a project that you've done up here, and you're going to create some metadata for it, and you're going to post the link to it so everyone else can click on it and download it and say, hey, look what Benjamin did, look what Cameron did, look what Daisy did, look what Mac did, look what Marlene did. Who else is online here? Look what Sarah did, or Caitlin, or whoever else is joining us later, or Travis, or whoever else. And I know they've done projects, they've written papers for geostats and whatever. So just post something up there. Over here in the modules. So if I go back right here, over here in the modules, I've kind of talked about some of the papers here. Environmental research, public health. I'm pretty sure if I've got an OSF there, Open Science Framework, I bet you down at the bottom we have under conclusions, funding, IRB statements. Has anyone heard the term IRB? Internal Review Board. So if we're doing something related to testing of people, or maybe even animals, but testing of people or animals, any type of human testing, we'd have to go through a review board. But we're just looking at data agglomerated at the zip code level. So that's kind of how we get around that. Informed consent, but right here, data availability statement sitting right here. No conflicts of interest, meaning I work for a drug company or whatever that, something where I might have something where I might have an interest related to that. But you can see I've posted that, posted there. But when we look under week number 7 here, you can see the Open Science Framework right here. And so what I want us to do is get a login, get started. It's a free open platform to support your research and enable collaboration. And so what I want you to do is sign up for it and post one resource to it. And when you post it, you are going to get a dedicated URL that you will post in the assignments, in the discussion board. And so you will go here in exercise number 6. And I will post a discussion board here for exercise number 6. is I just put your DOI so I can go see what Ariel posted versus Cameron versus Michael versus Andy or whoever else. And so, there's a lot of different open science out there. This is the stuff, this is Mulrooney's open science. So someone else's open science might be a little bit different, maybe going to Ag Commons or some other open data sources out there. But I'm a big fan of OSF, where we go and look what I have right here, and I can go and search these. It's got metadata. It's got files, this is the metadata that I've got here. It shows exactly what I did right here. Very rudimentary metadata. Here's the files. Here's the analytics. Look how many, oh, cool. Time of visits. These are the number, look at all these visits to my data. And so you can see, March 10th, 0 visits. All right, we had 4 visits March 9th. Man, today we've had 8 visits. Man, look at this. And the hour of the day. So you can, these are, this is, we're in a day and age of data-driven decision making. And so just for this little file, you can see all the information being kept about just my little corner of the research universe that, has been kind of highlighted right here. So you can imagine what some of the big stuff out there is going to be. So, I would really love to see, maybe I should give like an A to the person at the end of the semester has like the most views. That would be really cool, huh?
Just keep waiting.
Yeah.
Make it pod.
What's that?
Make it pod, they like refresh the page.
A what? Oh, okay. Yeah. So, all right. I still have 28, I got an hour and 58 minutes to kill here. So, no, I'm just kidding here. Are there any questions in my direction here? 3 main things, get an work ID. And before I leave today, I will post in the discussion board a link for you to put your OSF DOI. But big talking points, get an work ID so that you can put your research up there. It's going to be really important, you PhD students, once you start popping papers up there or being co-authors. I'm just about positive Chima has one already, right? You have, no, but an work ID. Yeah, he's got an work ID. Do you have one, Tony? Tony's got one up there already. And they've got published papers with us, and at some point in time, they will be first author published papers. This semester, Tony's looking in the other direction. Yes, we've made eye contact, so he's confirmed that as well. And I see some other people here that I'm making eye contact with. There she is, and there she is too. Okay, good. And then some other people too. No pressure, of course. But I know PhD students need to get those papers out there, and better sooner than later, especially when this stuff's fresh. And we're going to be doing some data wrangling next week. And so getting that work ID out there so it can be catapult you to the workforce or research or whatever you want to do. And then taking that TOPS NASA class, there's just a lot of buzzwords that you're going to hear that you haven't heard. You might hear some new things. They'll probably push the care a little bit more that I'm not as familiar with. And then just publishing a resource that you've already created to OSF. And so that I can look at something that you created, some of the data you've exported, something that you've created. Those of you taking geostats, you've already got data that you've published a paper for or done a paper for. Pop that up there. Make sure you tell me what we're looking at so that maybe someday other people will want to look at some of the things you're doing. And so I don't want to waste any more of your time because I know you got a lot of things to do in different directions as well as this class and other classes. So I'll kind of leave you all alone and start getting to it, but I'll be here for a little bit as I kind of update the exercise. And then next week, we're going to start talking about data wrangling, big data, which really isn't all that big, but it's going to be big for this class. And I'll stop recording.